What's going on? What's going on? You know, I am interested in mechanistic interpretability, which is a niche part of AI research. And I applied to this program called Arena, which trains people out in London how to conduct actual high quality mechanistic interpretability research. Unfortunately, I did not get accepted, although I must say that the rejection email was awfully kind. So, no hard feelings to the people at Arena. And also, just they have this really, really good online website full of a bunch of walkthroughs that I believe is, in essence, everything that is covered in the in person workshop series. Although I do believe that this is maybe 2 years old or so now, so it's probably a little bit outdated. But nevertheless, this is a really good resource, and I know that it is highly recommended. So I decided, even though I didn't make it in the real program, I'm gonna go through the program myself. And yeah, my goal is to just do one of these collab notebooks per day for the next 2 weeks or so until I've walked through the whole tutorial series. Of course, that may be subject to change. I may end up jumping around a bit. I may decide to spend my time on other things. We'll see what happens. But for now, I'm just going to start walking through these exercises and try to learn everything I can. So, this first notebook, they have a prior notebook that kind of just introduces you to the program. I'm not going to worry about that right now. I've read it myself, so there's no real need to read it again on here. And I will say that I have walked through this zero point 0.0 notebook before, although um, I didn't really try to sit with it and crack everything myself. I did rely a little bit heavily on the solutions notebook that they have here. And there was also just a lot of startup energy I had to devote to understanding the INOPS library, as you'll see later. INOPS and INSUM are these two linear algebra matrix multiplication libraries that they introduce here. So that's a significant part of it. You'll probably see me working through those docs too as well. So the goal really here is just to optimize for my own understanding. So however quick or long that takes is what it's going to be. So let's start. This section doesn't have exercises. It goes through a list of important concepts with reading material. Okay, so we're going to kind of speed through this, but the long and short of it is learning objectives, understand the structure and function of neural networks, learn essential linear algebra, understand core probability and stats, learn calculus, cover foundational information theory, enhance Python skills, INOPS, INSUM, and tensor manipulation. These sections are good. Engage with the tensor, understand the basics of Einstein's summation convention, learn how to use INOPS to perform basic tensor rearrangement, and INSUM to perform standard lin-alg. Core concepts knowledge. All right, you know, you got to know math. You should know some lin-alg. You should know some PNS. I didn't mean to say it like that. You should know some probit stats. Um, you should know calculus, information theory, Python, NumPy, PyTorch, INOPS, and INSUM, typing. All right, okay. What does this say? Let's read the meme. This is Git. It tracks collaborative work on projects through a beautifully distributed graph theory tree model. Cool. How do we use it? No idea. Just memorize these shell commands and type them to sync up. If you get errors, save your work elsewhere, delete the project, and download a fresh copy. Real. Very real. Okay. Um, all right, so let's get into the real thing. And hmm, I'm deciding whether I should work in here or work in a different collab notebook, but I think I'm gonna work in here. I don't think I'll need a GPU for this notebook, but we'll find out. I may have to rerun all of this, which would really suck. Let me, okay, I don't think that I'm gonna need to put anything on a GPU. Let's hope I'm right about that. I'm pretty sure I'm right. So we're connected to the CPU now, and the first, oh, you jump back here. Yeah, yeah. Okay, that ran cool. And now run this. And let's array equals np.load section directory numbers.numpy. So array is going to be a 4D numpy array. The first axes, I like to use visualizations when I think about higher dimensions. So if you, the first axis corresponds to the number, and the next three axes are channels. Okay, so you're gonna have the number one and some axes. So the channels, I kind of think about coming out this way, the height and the width, and the channels are just RGB respectively. You have the function utils.display array as image, which takes in a numpy array and displays it as an image. Cool, makes sense. There are two possible ways this function can be run. If the input is 3D, the dimensions are interpreted as channel, height, width. Okay, so channel, height, width. In other words, is an RGB image. If the input is two-dimensional, they're just interpreted as height and width, a monochrome image. For example, we can print array 0.shape, and we see that's 3 channels, 150 pixels height, 150 pixels width. Or you could think the 3 channels and then 150 rows of pixels and 150 columns of pixels. Print array 0.shape, and that is, we're ignoring those channels. So nothing's coming out this way. None of the, can you see this? Yeah, none of the colors, just the rows and the columns, which are all monochrome 0 to 1 pixel values. Array stacked equals inops.rearrange. So batch channel height width becomes channel height batch times width, and it's going to have us print array stack.shape, plotting all images stacked in a row. Before we print this, my supposition, so I think we have 9 images in a batch, because I believe this goes from 0 to 9. So you could think about this as 9, let's just do it like 9 channels is 3, height is 150, width is 150, and all of that is going to become 3 150, 9 times 150. So that's just going to have it be 3 colors and a height of 150 and a width of 9 times 150. So we're just going to see all the images, like all the numbers as a horizontal bar. Okay, cool. But it's actually 5, not 9. But same idea. A series of images follow below, which have been created using inops functions performed on R. You should work through these and try to produce each of the images yourself. This page also includes solutions, but you should only look at them after you've tried for at least 5 minutes. Note, if you find you're comfortable with the first half of these, you can skip to later sections if you prefer, since these aren't particularly conceptually important. Okay, we might do that, but we'll find out. We'll see how it goes. Like I said, I've already somewhat worked through this notebook. I think a useful thing for me to do here is to set up a timer, although you don't necessarily have to see it. But I'm going to set up a timer just so I can track whether I'm spending longer than 10 minutes on each question, and if I am, I will just look at the solution. So let's call this Marina, and cool. Okay, I have a timer going, and let's get to it. So column stacking, display solution arrays, image 1. Cool. My code here, define array 1. Wait, what is the exercise? Display solution array. Oh, okay, so we have to get that. I see. Let's just copy this here. We're gonna call it array 1. and inops.rearrange, instead of 5, 3, 150, 150, we want 3, 5 times 150 times 150. So we are, oh, you weren't supposed to see that. All right, so batch channel height width is just gonna be this thing right here. Channel height times the batch width, and we should get something beautiful. Oh, okay, what I do wrong? I need to actually think a little bit. That'll probably be good. So channel is 3. We're trying to multiply the height by the batch and then still have the 150 width. What it was before, oh, I see, I multiplied it on the wrong side, right? I put the B on the right. I shouldn't have done that, because this is lin alg. You gotta be mindful. So cool. Now column stacking and copying. In this example, we take just the first digit and copy it along rows using inops.repeat. So array 2, inops.repeat. And what are we trying to do here? We're trying to take the first digit. So array 0. But array 0 is the batch, right? Let's check out what array 0 is again. Okay. Okay, that's 3 channels. So yeah, array 0 is 0, is the number 0. What are we doing? We're taking the first digit and copying it along rows using inops.repeat. Now, I don't fully remember the details of inops.repeat. Are they in here? Okay, great, amazing. So we have the image, and then height, weight, not height, height width becomes height width times C. C equals 3, so change it to RGB format by repeating in each channel. Okay. Repeat image 2 times along height, vertical axis. This is kind of cheating, but that's how you can do it. I don't like this way. I'm gonna do it. So you just add a multiplier to it, essentially. Cool. So then height width becomes height 2 times the height, and then width, where height 2 equals 2. Uh-oh. What'd I do wrong? Height width, arrow, repeat H, W. Do I have to make it repeat? I don't think I do. What's the wrong shape? Expected 2 dims, received 3-dimensional tensor. Haha, okay. But we want it in color, so, and back here, cool. Row stacking and double copying. This example is pretty similar to the previous one, except that the part of the original image we need to slice and pass into inops.repeat also has a batch dimension of 2, since it includes the first 2 digits. Okay. So, okay. Except part of the original image we need to slice and pass into inops.repeat also has a batch dimension of 2, since it includes the first 2 digits. So let's just copy this. Let's be called array 3. And let's add this little batch right there and get rid of this. Pretty similar to the previous one, except the part of the original image we just slice and pass. Huh. So would it be, why is my brain not working? Maybe because it's 5 a.m. and I woke up at 4 a.m., but for whatever reason, I'm just having trouble remembering if this is going to be inclusive or not. A list slice in Python. Well, let's find out. My money, I would not bet on anything right now, but I'm pretty sure this is not inclusive. Yeah. Okay. But this will get me what I want. Cool. Cool. So, oh. uh, let's see. Repeat. Incorrect format. Link shape 2. Assertion error. Length of shape equals to 3. Huh. So, I mean, okay. Pretty similar to the previous one, except the part of the original image we need to slice and pass into INOPS to repeat. Also has a batch dimension of 2. So I'm pretty sure that this is the proper first step. Um, let's test something out. So what are we trying to test out? I just want to print it. Yeah. So if I just, okay, that's definitely invalid syntax. So that cannot, so this is the issue just in and of itself. Whereas if I do this, so that'll give me that. But I can't do that. But what I might be able to do is we looking we're looking let's just take this. Actually, let's take repeat since that's really what we're trying to use. We are here. So array 3 equals inops dot repeat, and let's just make it what it is. Batch channel height width is batch channel height width, and we're passing it in array, and let's see what we get there. That's incorrect. Oh yeah, array 3. Incorrect. Why is it incorrect? So, uh, so let's pretend we do this instead, and we're just gonna copy this. Try to find the error in our ways, as every man must do. So, if I were to do that, now, if I were to get rid of that and add the batch dimension onto here, question is, will this work? And the answer is no. And it's asserting length shape equals 2 or shape 0 equals 3. So, now, what if I were to do this? Input shape 2, 3. Okay, so I think what I could do is this was helpful if this is what solves the issue. But we gotta use that too. Amazing. Almost amazing. We need it to repeat. And the way that you make it repeat, I would need to also multiply this by 2. Okay, I can't do that. But maybe, just maybe, gotta submit my W-2 form. Beautiful. Cool, cool. Okay, now just copy all that to here. And we're good. So, stretching. We're gonna wanna stretch vertically by a factor of 2. And I believe this is also a repeat operation. So, okay. Array 4. And we just want arrays index 0. So there's no batch dimension that to be considered. Oh, shoot. Delete that, nephew. And get rid of that. So what we're gonna wanna do is we're gonna wanna stretch that height out. Yeah, this should work. Oh. Okay, yeah, I knew that was gonna happen. I know I said it would work, but I was not high confidence. Cool, that worked. And just the reason why it worked, I'm assuming, I mean, this is for really for me. I'm not, this is for selfish reasons. I'm shooting this right now. But if in the case that you're confused about any of this, I'd highly recommend going and checking out the INOPS and INSUM documentation. That's the only reason I kind of know what I'm doing, because I read those. And then also, if you are familiar with linear algebra, it should be straightforward why h2 times h is going to be different than h times h2. That's a linear algebra thing. It matters what side you multiply on. It's not the same as normal algebra. But yeah, that's why this stretched out instead of doubling. Now we're going to split channels. Is this a good use of my time? What instructions did it say again? If you think you get the general idea, you can skip to the next section. You shouldn't spend longer than 10 minutes per exercise. So we're on exercise 5. How many exercises are there? Whoa, seems like a lot. What is this? Broadcasting, okay. I think I get the general idea. Let's go to broadcasting now. Before we go through the next exercises, we'll need to address one important topic in tensor operations, broadcasting. Both NumPy and PyTorch have the same rules for broadcasting. When two tensors are involved in an element-wise operation, NumPy PyTorch tries to broadcast them, copying them along dimensions, so that they both have the same shape. The rules of broadcasting are as follows. 1. You can prepend dummy dimensions of size 1 to the start of a tensor until both have the same number of dimensions. After this point, if some dimension has size 1 in one of the tensors, it can be repeated until it matches the size of the corresponding dimension in the other tensor. To give a simple example, suppose we have a 2D batch of data, okay, 2D, height width, of shape n by k. We have n separate data points, each being a vector of length k. Suppose we want to add a vector vec of length k to each data point, okay? This is a valid operation because when we try and add these two objects together, vec gets prepended with a dummy dimension, so it has shape 1k, and both are 2D. Vec gets repeated along the first dimension, so it has shape nk, matching the shape of data. Then our output has shape nk, and elements output ij equals data ij plus vec j. Broadcasting can be a very easy place to make mistakes because it's easy to lose track of the exact shape of your tensors involved. As a warm-up exercise, Below are some examples of broadcasting. Can you figure out which are valid and which will raise errors? So x equals torch dot ones, 315, y equals torch dot ones, 145, z equals x plus y. What's the question again? Which are valid? So I'm torn because I would like to draw, but it really wouldn't be that fruitful. So this has 3 batches, 1 row, 5 columns. We're trying to add this thing with 1 batch, 4 rows, and 5 columns. And the question here is this a legal move? Okay. Let's draw it out. So so this is, you know, the way I think about batches is kind of like this. So this thing has 3 batches. Oh God. It's the wrong direction, my friend. Cool. Okay, so that's x. And it's, 1 by 5. And then y is over here all alone in no batch. Gets no batches. 4 by 5. Cool. So the question now is, can I do x plus y? And the thought process here is that what you would be trying to do, be trying to add this 4-rowed object. I guess if you so the whole idea of broadcasting, you're prepending dummy dimensions to the start of a tensor until both have the same number of dimensions. So these already have the same number of dimensions. After this point, if some dimension has size 1 in one of its tensors, it can be repeated until it matches the size of the corresponding dimension in the other tensor. So really what you're trying to do is you're creating this like fake dummy dimension and pretending that this thing gets batches. But really what we know is it doesn't get batches. So make that image in your mind. I can't even read that. Use app for you. Would you? No, I'm not rating you. I don't remember ever rating an app. Maybe when I was like 11. Okay, so back here. Oh, yeah, we'll leave that. So I'm just gonna say right now, my intuition is like, why would this work? Because the 4 and the 1, but then my brain is like, but bro, that's the whole idea, right? You're adding dummy dimensions. So you get, I really shouldn't have drawn these so thick. It shouldn't be thick like that. That was a mistake. There's an error in my ways. Let's do this. So come back here. And yeah, we'll do that. So we add the dummy batches on here, and now we're gonna add the dummy rows. This is what it's gonna be, something like that. Yeah, this is the intuition. You just add the dummies and you just make it work. You do what you gotta do, you just make it work. So this should work. My answer is valid. No errors. Final answer. This is valid because the 0th dimension of y and the 1st dimension of x can both be copied so that x and y have the same shape, 3, 4, 5. The resulting array Z will also have shape 3, 4, 5. The example illustrates an important point. It's not always the case that one of the tensors is strictly smaller and the other is strictly bigger. Sometimes both tensors will get expanded. Cool. And all right, let's see if we can do this without what we had to do. I'm pretty sure this is valid because it just will pretend that this will have a 1 on the end. Oh shoot, I should use my brain. We first need to expand y by appending a dimension to the front, and the last two dimensions of x are 2, 6, which won't broadcast with 8 2s. Okay, so important point to note, the dummy dimension is prepended. You cannot append the dummy dimension, but you can prepend. Cool. So 8 2 6, and then this one will have 1 2 6, and that gets 8. So yes, this is valid. And this is 10 20 30. And so you can prepend 1 21, and then that's a lot of so you can prepend dummy dimensions of size 1. So we can make this 121. So they will both have dimensions, and if some dimension has size 1 in one of the tensors, it can be repeated until it matches the size of the corresponding dimension in the other tensor. So this is valid. And then this, you can append it, so 4 1 and 1 4, and then it can become 4 4, and then this can become 4 4, and then this is valid. Cool. INOPS is a useful tool for reshaping tensors to enable broadcasting. You just need to add or remove a dummy dimension. Hold on. You don't need to use INOPS. Tensor.unsqueezeDim will give you a new tensor with a dummy dimension of size 1 inserted at position dim in the new tensor. And tensor.squeezeDim will give you a tensor with the dimension at position dim removed if it had size 1, otherwise nothing happens. So x equals torch.ones, 3 batch, 1 row, 5 width, or 3 channel, however you want to think about it. Print x.unsqueeze3.shape. So 3151 because we add a new dummy dimension at index 3. The end in the new tensor. You know what? I just want to tell you guys a little story. The reason I'm so tired today is because I woke up from a dream where I was in church and my grandma was complaining because she was uncomfortable, and the pastor just gets all angry and he's like, I made you comfortable. And my grandma's just tight, and the pastor kicks my grandma out, and I'm like, yo, my whole family's like, what are you doing? And the pastor comes up to me directly and is like, quit with that bullshit. And I'm like, what? Like, I don't even remember exactly what I said, but I said something. And then this guy comes up to me, he's like, you gotta get out of here. And then I just put my hand on his cheek, and then I said something, and then these guys came up to me, it was like cut up guys, and they were like, you're coming with us, my friend, you're coming outside. And I'm like, damn, I'm about to get my ass kicked. And then all of a sudden I look to my left and I just see Conor McGregor standing there with me, like ready to rock. And I'm like, Conor, I need your help. And he's like, of course, my friend. And so we go outside, and immediately I just get like this, a bunch of guys just are like pretty much grappling with me. I don't know why, it just immediately turned into a ground game, but we were grappling. I wasn't getting hit, but I was defending myself, but Conor was no help. And then the dream ended with like this pan out of me just being hugged by a big strong man because we're grappling and he can't really do much because my defense game is strong, but I had no offense. And I just see like, damn, this is how it ends, you know? And then I woke up and it was 4 a.m. So that's where my mind is at right now. And now I'm here doing Lin Alg. But anyway, we're gonna unsqueeze this X. And then we're gonna squeeze that X with 1. So that turns 315 into 35 because we remove the dimension at index 1. and then x squeeze 0 dot shape, and we get 3, 1, 5 because we don't remove the leading position. It has size 3. And just to reiterate, INOPS is a useful tool for reshaping tensors to enable broadcasting, but if you just need to add or remove a dummy dimension, you don't need to use INOPS because tensor.unsqueezeDim will give you a new tensor with a dummy dimension of size 1 inserted at position dim in the new tensor, and tensor.squeezeDim will give you a tensor with the dimension at position dim removed if it had size 1, otherwise nothing happens. Cool, cool, cool. So exercises, these are more representative of the kinds of INOPS operations you use in practice. Okay, so we'll be doing all of these. Next, we have a series of functions that you should implement using INOPS. So I'm just going to restart this counter I had started earlier, just to make sure I'm not spending too much time on this unnecessarily. So, series of functions implement with INOPS. In the drop-down below these exercises, you can find solutions. Define some helper functions, assert all equal, assert all close. Rearrange. We'll start with this simple rearrange operation. You're asked to return a particular tensor using only t.arange and inops.rearrange. The t.arange function is similar to the NumPy equivalent. Torch.arange start end will return a 1D tensor containing all the values from start to end minus 1 inclusive. Def rearrange 1, return the following tensor using only t.arange and inops.rearrange 3, 4, 5, 6, 7, 8. And so expected equals that, assert all equal. So, okay, so this is a simple rearrange operation. We're asked to return a particular tensor using only t.arange and inops.rearrange. The t.arange function is similar to the NumPy equivalent. Torch.arange start end will return a 1D tensor. Okay, so we're just trying to turn a 1D tensor into this 3x2 tensor. So tens equals t.arange. What is it? 3, 8. Print tens. And what I'm going to do is I'm going to separate these out. Actually, let's copy this. Okay, so what we're going to do is we're going to rearrange. Oh yeah, we just call it unindent. Oh, let's see. Not implemented. Oh, cool. Oh, I want that to be 9. That's weird. Okay, I think I saw an 8 there. I don't know. I'm tired. Okay. All right, so 3, 4, 5. Okay, so we have the numbers we need, and now what we want to do is we want to rearrange them. And the way that we rearrange them is with this inops.rearrange tens and what we're going to want is we're going to want height width. It's going to become 3 times the height. So the height is 1 and the width is 6. And we want the height to be 3. And we want the width to be 2. And the way that you do this, we want to break the 6 up into 3 and 2. So I'm trying to remember the trick here. I think it's like What's the trick? Is it like this? Oh. Expected 2 dims, received 1 dim tensor. Amazing. So, and we just want to return 10s. But we're gonna make sure we get that alignment right. Young AI alignment. Imagine if I was, ignore that. Just ignore everything. Copy, paste. Uh-oh. Whoa. See the error in my ways. Um, hmm. So what I did is I took 3, 4, 5, 6, 7, 8, and I unsqueezed it. Huh. I got too confident. A little too confident there. Okay. So what that did essentially is it made it vertical, and then, um, yeah. Okay. So height. This is me being stupid probably, but let's just see if it's as simple as that. Of course, it's as simple as that. Why is it as simple as that? Because it's lin alg, and multiplication is not, is it commutative? Involving the condition that a group of quantities connected by operators give the same result, whatever the order of quantities involved. Yes, multiplication in linear algebra is not commutative. So, weight, W2 is 3, and the width is 6. So we're saying 6 times 3, like trying to factor 3 out of the 6 makes W2 versus trying to factor. You know what? No, I need the clear understanding of this. So we're going to ask my guy Claude just to give us some clarity. I guess I shouldn't try to hide my friend Claude from you. So let me put him right here. Explain why in INOPS. Where's this I in sum? Which INOPS? Yeah, explain why in INOPS these are different. And when I do this, I get this. And when I do that, I get that. So the key difference is in how the inner dimension is interpreted and split in each case. Let's break it down step by step. In both examples, we're working with a tensor that probably looks like this initially. This is incorrect. I gotta correct you. Come on, man, you're more intelligent than me. Um, how do I do this? Okay, I guess let's start over. Um, yeah, okay. Show them the whole thing. Key differences in the ordering of dimensions within the parentheses. I know that the first version, the input tensor has shape 1, 6. In this pattern, H1 and WW2 means W is the faster changing dimension, the innermost. So we're essentially saying the W ranges first, then W2. Okay. Since W2 is 3, we're saying 2 ranges first, and then 3. When W2 equals 3, this means we interpret the 6 elements as varying along W. So for 2 elements, okay, so 3, 2, 3, 4, 5, 6, 6, 7. The arrangement W2H creates a tensor with the first dimension of size W2 times H, 3 times 1 equals 3, and the second dimension of size 2. Second version, the same input tensor. Here, W2W means W2 is the faster changing dimension. So we interpret the 6 elements as varying along W2 for 3 elements, then along W for 2 groups. So what comes to mind for me? And this is not the proper way. Yeah. We want it the other way. Okay. It's all starting to make sense. So it thinks about it as 3, 4, 5, and 6, 7, 8. Yeah. Okay. But this is how we want it. Oh no. It's not how we want it. We want this. Yeah. 3, 4, 5, 6, 7, 8. And yeah. Cool. Okay. Moving on. This exercise has the same pattern as the previous one. Return the following tensor using only t.arrange and inubs.rearrange. Okay, this one should be easy. Let's get rid of you, Claude. Thanks for nothing, man. All right. So one, two. Okay, cool. Just checking that I can be heard. So we want from 1 to 6. And we're gonna have 1, 2, 3, 4, 5, 6. And we want it to be 1, 2, 3, 4, 5, 6. So here we have want this 1, 2, 3, 4, 5, 6. So height should become 2, and the width. So okay, so what we're dealing with is height is 1, and width is, so it's just 6. We want this to become 2, 3, and thus, and we want to group the width in by 3s and with 2 groups. So with 2, width 2 is 2, and the height should get multiplied by width 2, and the width is just going to be the width. Got 1, 3, 5. Okay, I thought about it the wrong way again. There we go. And temperature average. Here you're given a, so just really to let this sink in my brain. This is saying 2, 3 groups. Or no, I got it backwards in my brain because the way Claude explained it. I think. I don't know. Just listen, I got beat up last night in my dreams, okay? Just bear with me. B1 temperature average. Here you're given a 1D tensor containing temperatures for each day. You should return a 1D tensor containing the average temperature for each week. I didn't read that. Okay. You are given a 1D tensor, one-dimensional tensor, containing temperatures for each day. So just think about it like this. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. To return a 1D tensor containing the average temperature for each week. So we want to add up all these values and divide it by 7. This is not a week. So just add up all the values, divide it by the length. This can be done in 2 separate operations, a reshape from 1D to 2D, followed by taking the mean over one of the axes. However, we encourage you to try and find a solution with inops.reduce in just a single line. Return, so temperatures average, return the average temperature for each week. Temps, a 1D temperature containing temperatures, a 1D tensor containing temperatures for each day. Length will be a multiple of 7. And the first 7 days are for the first week, second 7 days for the second week, etc. You can do all this with a single call to reduce. So we're going to get this input tensor temps, which is going to be a bunch of numbers, and expected, the average for each week. So, okay, what does reduce look like again? Reduce. Skadoosh. Yeah. Oh, I didn't do this one. Did I do any of the reduce ones? Okay, we're just gonna steal this. And what this is doing is reducing the array. 0, 1, 2, 3, 4, 5. Yeah. Okay. So I'm pretty sure what this is trying to have me do is go look at the docs. Boy, this is a lot, huh? This wants me to go look at the documentation and figure out how to do, I think, mean pooling is what it wants from me. Where am I? Temperature average. So I guess let's do that. Don't you hate it when you try to hit Control V or Command V and you hit Command C then Command V, so now you just got nothing? That's how I feel right now. Let's go to the inops reduce. By the way, fun fact, since we're talking about inops and einsum, always got to keep the man, the myth, the legend, young Albert with me at all times. Watching over me, making sure I stay on my P's and Q's. I get my math and my physics down right, down pat. Got my thought experiments running 24/7. So, inops reduce combines rearrangement and reduction using reader-friendly notation. And we want this global average pooling, or we just do BCHW, becomes BC, and the mean. So X starts, okay, X is 10, 20, 30, 40. When we pool from 10, 20, 30, 40 to just 10, 20, that would mean that we're taking the averages. So the batch, I think we're just going to get 10 batches, 20 channels. So a 10 by 20 tensor where each okay, so exercises. And okay, so all right, so inops, I'll reduce temps, um, fun fact, this little underscore is a nice way to think about prime, right? Like you have x and x prime, or like x and x hat, just like a little marker to put on things in Python, so you know you're changing it, but it's still still related to this underlying other variable. Inops style reduce temps. So temps and temps has a height and a width. And what we're trying to do is we're trying to go from 1 to, let's just say for the sake of argument, 7. We're trying to go 1, 7 to 1. Okay, so we'll say trying to go from 1 by 7n to just 1 by n. And we know we want to mean pool. So could it be as simple but then we would need to define n. Okay, I know this is kind of backwards. Input tensor. Oh. Okay, so what is this doing? It would appear that it is going height. Height is remaining 1. Oh, so that's clearly wrong. N is remaining 7, which is also clearly wrong. So I don't know if this is the right way to do it, but what I'm thinking is you could do length of temps divided by 7. So we'll just say n equals length temps divided by 7. And now we just make n. Reshape argument shape field to unpack the object of position 2 with error type must be a tuple of ints but got float. Okay. So it's not talking about n. Def reshape, self x shape, return x dot reshape shape, average temperatures temps, t dot tensor expected, reshape, argument shape, fifth unpack the object to position 2. Uh, hmm. So what if we just hack it? I feel like there's this way smarter way to do this, but we could just do this. Or we could even just, I think you can put integers in here. Okay, I should stop just button mashing and think. So I have the documentation right here. What we're trying to do is we're trying to go from this object, which is always going to be dimension 1 by 7n. And n is always going to be the length of our input tensor divided by 7. So h by wn is just unpacking that n, and we're trying to do, I don't know why I added that there actually. I'm just not thinking straight. It's always going to be one dimensional, the output, and it's going to have n columns. That makes sense. Yes, that makes sense. Now, the error here, reshape argument shape field to unpack the object of position 2 with error type must be tuple of ints but got float. Now, that is saying that you can't divide 7 by 2, which is what it would seem that we're trying to do here. But this is actually not the case because this is 14. So no, it's not. That's not what it's saying. It's not saying you can't divide 7 by 2. And I'm not even entirely sure that this is what it's referring to. Yes. So this line is the issue. And the problem with this line is hard to decipher, actually. So return, okay, let's just go one by one. Assert all close temps is this return apply recipe, apply recipe backend, recipe cast tensor, reduction type reduction, axes lengths, hashable axes lengths. If init shapes is not none, tensor equals backend. So backend dot reshape tensor init shapes. And then get out of here. You know what? Just let's get my buddy. I'm sorry, Claude. I'm cheating on you, but I'm going to my shorty Gemini. The error message argument shape failed to unpack the object position 2 with the error type must be ints. Got float indicates that the reshape function is receiving a float value instead of an integer for one of its dimensions. The issue lies in the calculation of weekly averages within the temperature's average function. Specifically, the length of the temps tensor 14 in this case is divided by 7. The result is 2.0, which is a float. This float value is then used. But I checked and it said it was of type int. So you're saying that if I were to do, you're saying that the solution, any, yeah. Okay, let's keep reading this. This is the suggested change. It's to make n an int in there. What? There's no way. What? That is stupid. If this works, I'm gonna be annoyed. I'm actually gonna be a little bit gratified. Okay, I knew that wouldn't work. Gemini is really dumb. Um, okay. Hmm. This better not work, honestly. I'd much rather spend more time with this and actually have it make sense than the solution be as dumb as this. Because this just seems pretty dumb if this is the solution. Yeah. Okay, error while processing mean reduction pattern. HW2 to H2. Okay. Let's start over. We got off the path because I was trying to be a little bit too fancy with that, just the N. So let's just make it 2. Let's just make this not extensible. So our tensor, let's just call it temps underscore equals ups dot reduce temps and height width is going to become height width except not really. 114 is going to become 1 2, and so we're just going to factor a 7 out of this thing. I should really think before I run code. What did I do? Wrong shape, expected 2 dims, received 1 dim tensor. Oh yeah. Temps equals temps dot unsqueeze. Gosh. Unsqueeze 0. Error while processing mean reduction pattern. Input tensor shape torch tensor 14. Additional info. Wrong shape expected 2 dims. Received 1 dim tensor. Temps. I see. None type object has no attribute shape. Assert actual, because I'm not returning anything. Shape mismatch, got torch size 1, 2. Huh. So that's right. Does it want me to unpack this? Okay. I really wasted a bunch of time on that trying to be fancy. It's okay though. Such is life. Temperature difference. Here we're asking you to subtract the average temperature from each week from the daily temperatures. You'll have to be careful of broadcasting here since your temperatures tensor has shape 14, comma, while your average temperature computed above has shape 2, comma. These are not broadcastable. Let's get this thing. I guess we'll keep it because this is a lot. Whoa, 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 wait, whoa. You know what? I think it might be break time. I'm gonna come back though. Right now, let's take a little quick break. So Where are we? All right, we're here. Temperature difference. Here we're asking you to subtract the average temperature from each week from the daily temperatures. You'll have to be careful of broadcasting here. Since your temperature's tensor has shape 14, while your average temperature computed above has shape 2, these are not broadcastable. So, all right. So temperature differences. Okay, so average temp per week equals temperatures average temps. Okay, so let's see temps. So let's just so print temps. We'll print average temp per week. So this is what we got for our temps tensor, and this is the averages, and we want to subtract each of So where my mind goes is you want to turn our 1/14 temps tensor into a 2/7 tensor, and you want to subtract the value in each column of our average temperature per week tensor from each row, each value in each row. So okay. So temps is 2. Sorry, no. Temps is, I know that they call it 14. I'm going to think about it as, well, I guess this does make sense. I'm going to think about it as this, though, which is not right, actually. That's literally wrong. It's just a nuance of the way that Python puts stuff out. So let's think about it like this. And then, yeah, this is this. And we want to make this 1, 2. Sorry, just checking that I have volume. Cool. Cool. Things are running. Cool. Okay. And then we want to make this 2/7. And we want to make this 1/2. So let's just call that 0. And now we'll print average temp per week dot shape. Okay. Prior to that, that didn't do anything. Oh, yeah, makes sense. Okay. Oh, okay, cool. Things are working as expected. And if I do, and then if I do temps equals inops dot rearrange temps we'll call that height, and we're gonna make it height width. Let's call it yeah, let's call it weeks, days. I'm confusing myself. Yeah, so, okay. Yeah, so height is 14. Let me just write the dimensions again, even though they're right there. Height is 14. We have this object that is 14 by, oh, I see. Um, Temps, unsqueeze. And now if I do print temps.shape, temps underscore, and yeah, so height width is now 1 by 14, and what we want is to be 2 by 7. So we're gonna need to unpack the 2 and the 7 in here. So we want 7 items in 2 groups. Yeah, 7 items, 2 groups. So W by W2, where W2 is 2, and this should be height times W2, and then W, and then if I do temps underscore dot shape, print temps underscore dot shape, we get 2 by 7, just 2 rows of 7 members. Cool. Let's do some cleanup. And yeah, cool. So now the shape of temps is we have a 2 by 7 tensor of daily temperatures, and then we have this ATP W, so average temp per week, which is a 1 by 2 tensor. 1 by 2, and we want to subtract. I don't know if this is the right way to do it for the shape of that one, but the idea, if I come back up to here, yeah, so 2 by 7, and we would want to subtract something that's 1 by 2. It seems like it would be easier. So yeah, this is where it would help if I had taken linear algebra. My class starts in 2 weeks. This is part of why I was dreading this, is because it's like there's so much of deep learning that's just like way easier once you just understand the requisite math. And I'm at a point now where I understand calculus, I understand prob and stats, I understand linear algebra on some level. I mean, I've read books on it on my own. Well, I've read a book about using Python for linear algebra. But there's just a difference in the amount of knowledge that you gain from watching 3 blue, 1 brown linear algebra videos versus taking a course where you're like, damn, I got to get this in my head because I will be tested. So that'll be good. But at least for right now, I'm struggling with something that feels awfully simple, but it's okay. This is part of the learning process. So what is the issue here? The issue is that we have these 2 tensors. One is a 2 by 7 tensor. So let's do the thing. Let's draw it out. How do I clear screen? Okay. So let's change the color. I don't like blue. I mean, I don't like red very much. I like this is cool. I like that. So, okay. So what do we have? We have a 2 by 7 tensor. 2 by 7. And we have a 1 by 2 tensor. And we could think about it as one, two, three, four, five. Oh, I did that wrong. 1, 2, 3, 4, 5. Yeah, 6, 7. Okay, so what do we want to do? And yeah, let's do that. Yeah. Okay, so we want to subtract, call that a dot, call that a dash. We want to subtract the dot from here, from all of these. Yeah, subtract the dot. And we want to subtract the dash from all of these. And just to get a taste for how matrix algebra works, I wanted to keep that on the screen, please. Thank you. Just to get a refresher on how matrix algebra works, I'm going to open up my terminal. I am going to open up a little IPython. I'm going to import NumPy as NP. And I'm going to create a matrix 1 equals 1, 2, 3, 4. Actually, why even make it that complicated? Make it even simpler. Actually, no, it'll be fine. 1, 2, 3, 4. And that's mat 1, and then mat 2. We're just gonna make it the same thing. 1, 2, 3. And then mat 1 minus mat 2. Oh, damn it, I didn't mean to do that. How do you, okay. Mat 1, mat 2, and then print mat 1 minus mat 2. Unsupported types, list. So this is where good old NumPy is going to help me out. np.array. Thanks, NumPy. np.array 1, 2. You know what? I could literally just say mat 2 equals mat 1. That's way easier. And then now, yeah. Whoa. As you can tell, I don't often use IPython, but when I do, it looks cool, right? I got the matrix colorway set up. So, all right. So what is happening there? It's doing an element-wise subtraction. Now, in the case that mat 2 were, let's say instead, so let's say, okay, let's up the ante, right? Let's make mat 1 np.array. And there's definitely a simpler way to do this, but I'm going to do it the dummy way. 1, 1, 1, 1, 1, 1, 1. Okay. 1, 1, 1, 1, 1, 1, 1. Okay. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, this is supposed to simulate our temps array, 2 by 7. Uh-oh. Cool. What now? Oh, I see. All right. Integrate this, insert that. Okay, cool. And then mat 2, 1, 2. Oh, make it np.array. And now we print. How do I autocomplete in this? If I hit tab, it doesn't work. I'm sorry, this is gonna bug me unless I figure out the answer. How to autocomplete in IPython. Yeah, I mean, how to type part of a name and press tab. Uh, tab isn't working. I'm pressing tab. All right, whatever. It's fine. Just leave me alone. I'll type it out, okay? Mat 1 minus mat 2. Okay, yeah. Operands cannot be broadcast together with shapes 2, 7 and 1, 2. And all right, Claude, I'm sorry I was mean to you. This is a problem that I'm okay asking for your help on because it's abstracted enough from the initial problem. Yeah, so I'm just gonna say help. And let's see what he's got for me. So we're running into a broadcasting error. It's a common issue when trying to perform operations on arrays with incompatible shapes. Problems okay, I understand. Yeah, so for broadcasting to work, the dimensions need to be compatible. This means either they're exactly the same shape, one dimension is 1, which can be broadcast to match other dimensions. One array has fewer dimensions, which can be broadcast to match the leading dimensions of the larger array. In your case, the shapes 2, 7, and 1, 2 are incompatible. Okay, so option 1 is to reshape matrix 2 to be compatible, which involves, so the impression I get here is that I completely went down the wrong pathway of deduction when I decided to change temps to a 2 by 7 tensor. It's the impression I currently have. Let's see if that was accurate. Just take the first row, first 2 columns, get the shape. So now reshaped 1, 2, 1, 2. Oh, what is that? Oh, I see. Yeah. So I think maybe I didn't do it as wrong as I'm acting. If I do unsqueeze 1, then I get 2, 7, 2, 1. And then if I were to I don't know, let's just call it mat equals temps minus ATPW, and then I print mat. Okay, so I didn't go down the completely wrong path. Actually, I was very close. I just unsqueezed on the wrong dimension. And then if I, this is definitely not the optimal way to do this, but it's okay. Mat equals inops dot rearrange mat, and we have a height and width, and we want it to just be, whoa, height times width. And is that all we need? Yeah, yeah, cool. And then we return mat underscore Tensor likes are not close. Mismatched elements. Oh, okay. Yeah, not quite. So the first element is correct. Second element is not. And 1, 2, 3, 4, 5, 6, 7. Huh. So the first and last elements are correct. And all of the elements, like these are the same set of numbers, but the order is incorrect. And the solution may just be as simple as this. I'm getting confused by having these other things printing out, so let's get rid of this stuff. So I think this moved us further away from the goal. So the question is, why is this happening? First of all, let's ask ourselves if the temps tensor is shaped properly. So let's make this even more clear. Temps prime, and we'll say print temps, well, temps orig. So okay, yeah. So already we see that we did this incorrectly. We're gonna want this. Okay. Oh, great. Cool. As simple as that. So that was a fun one. And we still got plenty to go. And as a man of my word, that break was not that interval of effort was not meant to last that long. I gotta take another quick break, so I'll be right back. You know, it's really impossible to say because of the two breaks I've taken. Uh, but I'm realizing now that I've been doing this for I think more than 45 minutes. My timer says an hour and 8 minutes, specifically for this operations and broadcasting section. And it makes me wonder whether I've hit the point of diminishing returns. I do wonder that. Now, am I maybe chickening out of doing all these problems? Maybe, you could say that to some extent, maybe, probably. But am I bored? I wouldn't say bored. Hmm. Maybe I'm overthinking things. Let's at least do B3 and see how we feel after that. So we need to subtract the average and divide by the standard deviation. Note that you can pass t.std into the inops.reduce function to return the standard deviation of the values you're reducing over. So, okay. Subtract the average and divide by the standard deviation. So we've already subtracted the average. And so subtract by the average, and divide by the standard deviation. So let's see what's the standard deviation temps. Equals temps dot std, print std. Yeah, this is not what I expected. Built-in methods, std of tensor object. Okay, maybe, yeah. Okay, so the standard deviation of our tensor is 5. Yes, because this is the temperatures tensor. But if we do temperatures differences, huh? Um, hmm. I have all these print statements. Get rid of this. Yeah. So, okay. And does it make sense that 5 divided by 3? Um, what am I saying? Yeah, no, it doesn't make sense. Hmm. Subtract the average. So first we were meant to calculate the average of each week. Then we subtracted the average for the week the day belongs to get these the differences between that day's temperature and the average for its given week. And then for each day, we want to subtract the weekly average, which we've already done, and divide by the weekly standard deviation. So what we need to do is to take the standard deviation not of the entire input tensor, but of each row of our of this thing. No, sorry. Okay, so uh okay, so that becomes this, and this becomes this, and print it. Hmm. We're gonna have to unsqueeze it, unfortunately. And I know that they said there was an easier way to do this, at least I think. But whatever, it's just like you brute force it. It's the only way to live life. Uh, inops.rearrange, error while processing rearrange reduction pattern HW7 to HW input tensor shape towards additional info. Non-unitary anonymous axes are not supported in rearrange. I see. No, that wasn't it. $114. Uh, um, okay, so and is that the right way? $772.70, and no, it's the other way. Yeah, whoa, 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 whoa. Not what I meant. I really am gonna have to understand this at some point. Yeah, that looks better. Yeah, that's good. So, okay, yeah, and now we have this. It's just so what's our goal? Our goal is for each day, subtract the weekly average and divide by the weekly standard deviation. So now we have this tensor, which gives us the weeks, and we can compute the weekly standard deviation by using inops.reduce. And instead of setting this value to mean, we should be able to set it to our t.std function by doing command V inops.reduce temps, which is currently 2.7, and we want it to be 1.2. Now, note that you can pass this into the inops. So is it as simple as this? I doubt it. Standard dev. Okay. And we'll print that. Yeah. I mean, visually this makes sense, right? The first week is a lot more compact in the range of values it takes on, whereas it only, this first week only ranges from 0 to 5. This one ranges from 2 to 15. I'm saying different numbers. I'm making it sound wrong. It ranges from the first week ranges from 70 to 75. The second week ranges from 72 to 85. So it makes sense it would have a much higher standard deviation. So just visually these look right. And now we have the standard deviation. And what our goal is for each day, subtract the weekly average and divide by the weekly standard deviation. So we already have a function that lets us subtract the average for the day the week belongs to, or for the week the day belongs to. So we could do temps diff equals temperature differences temps and print temps diff. I see. Yeah, I see. Okay. Hmm. So, oh yeah, we don't need to do that. So this looks right to me. Yeah, yeah. Uh, Back here, back here. Um, Start all close. Actual t dot tensor expected. So this is our differences. Temps diff. And then now we want to divide each by the standard deviation. And we have this. So the same logic that we used up here, given that we're dealing with things of the same dimension, maybe, possibly, I think. No, no. We're close, but we need to get these into the right dimensions. So print. So like really what we want to do is we want to do temps diff divided by temps standard dev. However, I don't think these are currently in the proper dimensions for us to do that. So if I do temps diff dot shape and temps standard dev dot shape, I'm gonna see 14 and 2 by 1. So we know that we want temps diff to be 2 by 7. Actually, not necessarily. It seems like it would be an easier intermediate step, because up here, what we did was we made it 2 by 7, calculated the averages, then subtracted the averages from the temperatures, and then rearranged it to be a vector. And so we can sort of copy this and yeah, so average temperature per week in our case is now temps diff, which we need to unsqueeze. Temps diff, and we'll print temps diff dot shape. Amazing. And now we want to divide our temps diff by our no. We have to rearrange it first. Temps diff equals inops dot rearrange temps diff, and 14 by 1, so we want it to be 2 by 7. So height width becomes height width, except not really though. So I tend to do this wrong, so let's try doing it the way I typically don't do it. So we want to make H2, we want H to have value 2, which means H2 is 7, and we will do W times H2, and now let's print temps diff double underscore, and just for good measure, let's also print its shape. Yeah, you're right, that's invalid syntax. So after that, yeah, I did it the wrong way. Let's really drill into this, think about why I'm doing it the wrong way. So we start out where height is 14. And what we do in this example is we do 7 and 2. So that means that we have 7 elements in 2 groups. So I'm really just, this is I'm sure that this is redundant. I don't know why you're watching this. If you have this knowledge just well drilled in your head, you probably would have clicked off already. It's fine. No hard feelings. Uh, but let's really drill this into our heads. What is going on here? So, right, we start out with this column vector, and this thing has 14 items. 1, 2, 3, 4, 5, 6, 7, and yeah, 2, 4. It's fine. This is 14 by 1. So we have this, and we'll just call this 1, 2, 3, 4, and you get the picture. 4, 5, 6, 7, and then 8, 9, 10, and yeah, I know that looks like an 11, but there's nothing I could really, you know what? Gosh, please don't do that ever again. Okay, yeah, 11, 12, 13, 14, 15. Cool. Oh, wait, what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, cool. So this is the picture, and we want to transform this into, oh gosh, that's not, I don't like that. Yeah, so we want to transform this into something like this. Yeah. Yeah. Okay. So, okay. And the way that we need to do that is we want to go 1, 2, 3, bop, 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 and we want this to be 8, 9, 10, bop, 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 bop. Okay. This is my normal wake up time. That dream really messed me up, guys. No, so, okay. So, let's think. Let us do that. So, how do we go from here to here? Well, one way to do it, which would be the wrong way, would be to factor out the 7 on the right and to leave the 2 on the, to factor out the 7 on the left and to leave the 2 on the right. Now, this, if that is the wrong way, that would imply that whatever we factor out on the left, um, it's not that it becomes our rows, because we still have this 2 by 7 dimensional object, but clearly what H2H is doing is resulting in something like, let's just do, it's resulting in something like 1, 2, so negative 0.5, yeah, 3, 4, 5, 6. Okay, yeah. So it groups them in 2s, and then it moves to the next column, and it's grouping them in 2s vertically. And another thing to point out, my memory is just dog water right now. But let me just refresh my memory as to what's happening really right now in this function. And to do that, I'll need to do this. And so what's happening so far? For each day, we're subtracting the weekly average and dividing by the weekly standard deviation. That's the goal. We need to pass t.std to reduce. And so first what we do is we unsqueeze temps to turn our one-dimensional array into a 1 by 14 array, or tensor, let's say. So now temps is a 1 by 14 tensor of just 14 daily temperatures. Next, we rearrange that. So we take our 1 by 14 and we get we factor out the 2 on the right, on the left, sorry. So 2 items and 7 groups. See, I have that backwards. That's a gap in my understanding. Really, it's 2 groups of 7 items. And then we have now 2 groups of, 2 groups and 7 items in each group. That makes sense. And now that's our temps. And it has the days of the 2 weeks and 7 days, right? So what is on the left is our groups, and what is on the right is our items. It's a good way to think about it, which also goes in line with the idea of like rows and columns are, I know I'm using the word items here twice, but let's say objects and features. So objects have features and groups have items. What is on the left is the categorical value, and sort of what is on the right is the qualitative value or descriptive value, just a way of framing it, right? Left category, and right what's the term? You know, item. We'll just say that, okay? I know that's not the right way of thinking about it though. Instantiation. Regardless, I get it. Okay, so temps standard deviation equals INOPS.reduce temps. So now what we're doing is we're taking this thing, and we reduce it to get the standard deviation of each row. We do H and we put it into effectively 2 groups of 7 objects, and this becomes, so this is 2 by 7, and then we get 2 by temps. Yeah, so this is 2 by 7. This is 2 by 1. Yeah. Yeah. Okay. Yeah. uh Interesting. Visually that makes sense, but now I see it's contradictory to what I initially intended, which means changing that might be the necessary step. I'll consider doing that. So that's not really what I meant to do, huh? In this scenario, W is 2 and H is 1. No. H is 2, W is 1. Because temps underscore is 2 by 7, not 2 by 14. So, so what I really meant to do is I meant to go, yeah. So again, what is on the right is the category, and here's an item or an object feature. And so if I want these 2 categories we have on the right, we're going to want 2. Yeah, so and then this would just be W, and then still do that, but now you would have is that right? No, you don't need this 7 here. W's already. Actually, no, I think this is better. I think the original way was better. But I need to make a note that we end up with 2, 1. Okay. And then we print, and then we calculate the difference. So temps diff equals temperatures difference temps, and that gets us this, which checks out. Yeah. Does it check out? Yeah. Huh. Yeah. Yeah. Huh. No, the only thing I'm confused by. Oh, I see. Okay. No, it makes sense. Yeah. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yeah. Okay. And its shape is just 14. So our differences. And then the standard deviation is up here. And then temps diff equals temps diff dot unsqueeze. And then its shape is 14 by 1. So the main things we want to be focusing on are, at this point these are the main things we want to focus on. So our standard deviation tensor, and its shape is 2 by 1. This is our differences tensor, and its shape is 14 by 1. And then we don't need to see this again. Or we don't. Oh, yeah. So what we tried to do is we tried to rearrange this, which was silly. Why did we try to do that? I see, because we wanted to be able to broadcast. I see. So if our standard deviation tensor was 2 by 1, our lives would be much easier. So I'm sure that there's an easy function to swap dimensions. If I have a 2 by 1 tensor, how to make it a 1 by 2 tensor. Transpose, yeah. Okay, so let's just print let's do I need this? I don't know. Let's just get rid of it. So it's not gonna do anything. Print, throw a new line in there. And what do we want? We want temps standard dev dot t. And yeah. Shape Yeah. Okay. So standard dev double underscore. Oh, I did that on the wrong line. Yeah, but let's copy that and then go back. Yep. And we'll copy this and get rid of that. And so now, is there a world where we can just run it, you know? Just run that. Uh okay, so 2 1 and 1 2, and what I was trying to do before was trying to rearrange our differences matrix, but I don't need to do that anymore. All I need to do is divide our differences matrix by our um by our standard deviation matrix, and it seems like that will work out. I mean, negative 0.57 divided by 1.7 is about negative 0.33, and 4 divided by 4.472 seems like it should be about 0.89. So if I just now do mat equals, I don't think I'm going to need this line, but mat equals temps diff divided by temps standard dev. Oh, I put 2 underscores on that thing. Yeah, so, and then I print mat. So we're close. We're close. The numbers exist. They're all there. However, huh. Interesting. Why is this happening? It's hmm, sort of like rolling it out, because from here, okay, from here down to here, we see all the values for week 1. And then from here down to here, we see all the values for week 2. So I think, and of course that would happen. We want it to be, hmm, we want it to be 2 by 7 and then to roll it out to 1 by 14. But instead, right now, we're doing 14 by 1, which it makes sense that this would happen. Temps diff is not the right dimension before the division operation. It would be great, though, if it were instead, um, it would be, let me, um, yeah, so So okay. So we have this 14 by 1, we have this 1 by 2, and instead what we need is we need temps diff. Now I see why I was doing that before. If I just bring this back, yeah, so this is one of those let Jesus take the wheel type of moments, which is never good in coding. It's actually terrible to do. But you know, we're having fun. This is a fun, this is for fun. So let's just call this, yeah, temps diff prime. And yeah, this is messy, but um, uh, yeah, so temps diff prime is 2 by 7. This is not what we were trying to do. Trying to make it 7 by 2, which means okay. And yeah. So, yep. Yeah. Okay. That's better. Now we need to unpack this. And one way to do that might be um, what are its dimensions? Right now its dimensions are 2 rows, 7 items, and we want it to be 1 row, 14 columns. So all we need to do is we need to we want that to be 1, so one thing, items, 2, and I think we actually, and no, 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 yeah, and this and W groups or items or H2 and print. Does this make sense? H, I need to, this H2 is 2. So H becomes 1 and W, and that becomes 14. And this is mat underscore. And what is going wrong here? Arrow processing rearrange reduction pattern. Input tensor shape 7.2. Oh, I see. Seven by two. So what should get factored out is the 7. Yeah. Yeah. Looks good. Cool. So now, shape mismatch 1 by 14. But if we do this, then test pass. Cool. So yeah, that took much longer than it should have taken. Actually, no, let me not even put that on it. You take the amount of time it takes you to learn, right? Learning is forever, at least until my brain turns to mush. But it's okay. I did it the hard way, and now I'm better for it. So that was fun. I'm not going to spend all day doing the rest of these, though. I do think I've probably reached a point of diminishing returns. So I feel good, though. I feel like I made some progress getting more used to INOPS and just matrix algebra in general. So next time I'm dealing with these arena walkthroughs, I'm going to get to the fun stuff, and I'm going to go to 0.1, which is ray tracing, right? Like all of this was just prerequisite. But what's coming up next on the docket is ray tracing. So actually doing some rays and segments, learn how to create PyTorch tensors in a variety of ways, understand how to parameterize lines and rays. It'll be cool. It'll be fun. We'll be dealing with some 2D and some 3D stuff. I'm excited, but that's not for right now.